Hey everybody, welcome to our first final review. We are going to be covering chapters 1 through 3 today. The video is going to be a little bit longer because we are going to be going through several problems that I want you to be prepared for and to review. You're also going to have a worksheet that goes along with these chapters, so I know that you kind of remember those concepts. Some of them might be easy to remember. Some of them might be a little bit harder. Okay, I would definitely look over, make sure you go through this and write down the review that we go through. We're not going to cover every single concept and every single topic because that would take, well, 2 quarters, just like it has the last 2 quarters. So we're going to just kind of pinpoint different parts of it. I'm going to tell you exactly what the concepts were that were covered. But if you go through this review, you go through the worksheet, you look over your notes, your postulates, your theorems, I don't see any problem as to why you would not be do very well on this test. So just pay attention. If you have any questions from the past, please ask me so I can answer those questions. Sweet. All right, so let's get started. Okay, so what we're going to do at the beginning of each chapter, I guess for chapters 1, 2, and 3, I'm going to give you the concepts and the topics that we covered, and then we're going to do about 3 review problems, and then move on to the next chapter and just repeat that for chapters 2 and 3. Okay, so if you remember patterns, we looked at different patterns. So if I gave you the pattern of 2, 4, 6, could you give me the next 3 numbers in that pattern and then tell me the rules to that pattern? Okay, conjectures. We talked about conjectures and counterexamples. If I give you a conjecture, can you prove it false by giving me a counterexample? And we'll go over that in just a moment. Points, lines, and planes. Okay, remember that we've done this not just from chapter 1, but in 2 through 6, that you need to make sure that you label each thing correctly. Okay, as far as a line segment, a plane. Don't forget that symbol for a plane. If I have plane D, E, F, G, okay, don't forget that that is a plane right there. Okay, collinear points and coplanar points. When you look at collinear, you will notice that word line in there. Okay, and coplanar, plane. Collinear, if you remember, right here, collinear means on the same line. So if I give you a point that is collinear, okay, I'm going to give you, let's say, A and B. Okay, A and B are collinear. A, C, and B are now collinear. However, if I put point D out here, A, C, B, and D are not collinear. A, C, and D are not collinear. They do not lie on the same line. Okay, so collinear and coplanar. Okay, if you go to coplanar, all 4 of these points now would be coplanar. Okay, they're not all collinear because they're not on the same line, but they do lie on the exact same plane. So it is coplanar right there. Okay, lengths of segments. If I give you 2 points, so if I give you A and B, looking at that above line on ACB, if I give you 2 coordinates like 2, 4 and 2, 19, okay, would you be able to find the distance between A and B? Okay, and the length of that entire segment, the distance of the entire of between A and C and B and A and B. Okay, we're going to cover that in just a little bit. And then, of course, classifying angle measures, or classifying an angle by its measure. If you look at that angle measure, can you know it's acute, know it's obtuse, know that it's straight or right? Okay, so don't forget about those classifying angles. Okay, so those are the topics that we covered. Let's go through a few problems. All right, so this first example, I want you to show the conjecture is false by finding a counterexample. Give me an example that makes that conjecture not true, a counterexample. So the first one says if you multiply 2 numbers together, then the product will be larger than either of the initial digits. And then conjecture for the second one, if all squares are rectangles, then all rectangles are squares. Give me a a counterexample to both of those. Give them a shot. All right, so this very first one, if you multiply two numbers together, then the product will be larger than either of the initial digits. Okay, so if I start out and I take, let's say, 2 times 4. 2 times 4 is 8. Well, that is just an example. That just proves it. Okay, because my product, which is 8, is larger than both 2 and 4. Okay, so that does not give me a counterexample. However, if I do a number like 2 times 0, what's 2 times 0? 0, of course. My product here, 0, is not larger than both of my digits. It's actually smaller than 2, and it's actually the same as 0. Okay, so does that fit that conjecture? No. So my counterexample, I just gave one right there. Okay, 2 times 0 would be equal to 0. That would be my explanation. All right, next one, we have if all squares are rectangles, then all rectangles are squares. Here we would go through the definition of a rectangle and of a square. Okay, so what is the definition of a square? You have 4 90-degree angles and all sides congruent. What is the definition of a rectangle? Well, you have 4 90-degree angles. So if I make a rectangle right here that has 4 90-degree angles, but notice not all my sides are congruent. Okay, and right there shows that not all rectangles are going to be squares, because that right there, this shape down there, is going to be a rectangle, but it is not a square. All right, so there's my first my counterexample to that problem. All right, awesome. So, okay, if you remember distances, okay, I'm going to show you. There's two different ways we can find distance of a point on a coordinate plane. Okay, what I want you to do is I want you to try to find x and y. I will show you both ways. Hopefully that kind of jogs your memory a little bit, and then we'll move on. Okay, so give x, y, and jk, just kidding, a shot here. All right, so finding the distance of the given segment. Okay, so when we look at distances, we know that distances cannot be negative. Okay, if I go from Mahtomedi to St. Paul, my odometer will go up. Let's say it's 10 miles from Mahtomedi to St. Paul. Okay, now if I go back from St. Paul to Mahtomedi, and I went like a round trip from Mahtomedi to St. Paul to Mahtomedi, I didn't go 0 miles. Okay, just because I went forward and backward, I didn't go 0 miles. I went a total of 20 miles. I found the absolute value. A distance is an absolute value. Okay, so to find the distance between x and y, we can look at the coordinate that changes. Notice my x-coordinate stays the same at -4. However, my y-coordinate changes. So I would take the absolute value of the difference between those two numbers, minus a -2. Okay, when I do this, I have 7 minus a -2, add its opposite, and the distance would be 9. Okay, so I have 9 place values in between x and y. Okay, the second way, if you look at jk, well, if it's on a coordinate plane, we can just count the number or the distance behind there. Okay, or the distance from jk. So I'm going to start at j, and all I'm going to do is count. I'm going to count 1, 2, 3, 4, and I'm done. Okay, I went from j to k. I went 4 units to the right, because each of those boxes represent 1 unit. Okay, so I went 4 units to the right, and I got to 4. Again, I would have 4 units. Okay, whoops, I forgot units on the 9 units. Okay, so I have distances. Okay, so that's distance. You can subtract, if given a coordinate pair, you can subtract the coordinate plane that, or coordinate pair, that coordinate that changes, sorry. Okay, so my y changes in x and y. jk, I just counted. I could also have subtracted 0 minus 4 and gotten a distance of 4 as well, because my x values on j and k change. Awesome. Moving on. Okay, so here it says find the measure of each angle and classify each angle. Okay, so if you look at these angles, ABC, ABD, and EBD, if I look at those angles, we talked a little bit about the angle addition postulate, okay, when we can find angles like EBD, when we can find angles like ABC, adding angles together. Okay, so I want you to try ABC, ABD, and EBD just to see if you can find those angles and make sure you classify them. All right, so ABC, if we look at ABC, we know that ABC is going to be this angle right here, that large angle, and we know that ABC is broken up into ABD and DBC. Okay, so because it's broken up into, and we know those two angle measures of 64 and 32, all we're going to do is add 64 and 32 together. Okay, so when we add 64 and 32, we get a total of 96 degrees because I took 64 plus 32. All right, so 64 plus 32 is 96. Now I have to classify that angle, and a 96 degree angle is going to be obtuse. Why is that obtuse? Because it's greater than 90 degrees. An angle that's greater than 90 degrees but less than 180 is going to be an obtuse angle. Sweet. Okay, ABD. Now I'm looking at this red angle, not triangle. I'm already moving ahead. Okay, that red angle right there, ABD, and I want to find that angle measure. Well, this one's pretty easy. It already gives me that angle measure. I don't have to do anything to find that. Okay, so if I look at that angle measure, it is just 64 degrees. Okay, 64 degree angle is going to be what type of angle? Well, it's less than 90 degrees, so it has to be so cute. It has to be so cute. It's an acute angle because it's less than 90 because it's so small. Okay, an acute angle. Awesome. Last but not least, we have EBD. An EBD angle, if you notice, that's going to be this final angle that I am going to put here in yellow. All right, so if you look at this yellow angle right here, yellow, 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 yellow like the sun. That's a new color for us, huh? Okay, so if I look at yellow, you will notice I will be finding that angle measure. When you do that, notice that EBC, what type of angle is EBC? This bottom angle here. That's a straight angle. Okay, straight angle. What do we know about straight angles? It's 180 degrees. Okay, so I know the entire thing of EBC is 180 degrees. Okay, so now I just need to find, if I found this angle measure, I could use that angle addition postulate to add ABE and ABD together. Alright, so let's give this one a shot. So how do I do that? I would take 180, and I already know what ABC is together, 64 and 32, is going to be minus 96. When I subtract these, okay, I get a total of 84 degrees. So I know for a fact that ABE is going to be 84 degrees. Okay? But that's not, or sorry, ABE, that's not the angle I'm looking for. I'm looking for EBD. So I need to follow through, take 84 and 64 to find EBD. So 84 plus 64. When I add those together, I get 148. And my angle for EBD is 148 degrees. Okay? But I'm not done because it asks for find the measure of each angle and classify each angle. So classification, we already went over that. Classification of a 148 degree angle would be obtuse. Awesome. Moving on to Chapter 2. We're moving on to Chapter 2. Okay, again, if you don't quite remember everything from Chapter 1, bring that up tomorrow when we have that homework so I can look at any questions that you have. So make sure you ask me, because our test is coming next Wednesday. All right, so segment bisectors, angle bisectors. If we remember the segment bisectors and angle bisectors, that's going to cut a segment or an angle in half. Okay, so if I look at this angle of a very original angle of ABC, and I told you that ray BD bisected ABC. If it's a bisector, that tells me that ABD is going to be congruent to BDC. Sorry, DBC, not BDC. DBC. That bisector cuts that angle in half. Same thing with the segment bisector. It cuts the segment in half. Okay? Complementary and supplementary angles. This is something that I think is easy to slip or mix up. Okay? In the past, supplementary angles add up to equal 180 degrees, and complementary add up to equal 90 degrees. Okay? So complementary equals 90 degrees. Now, I have seen in the past on a few of the more recent tests that complementary angles, some people had that added up to 80 degrees or 100 degrees. Not there, okay? 90 degrees. 90 degrees for complementary angles. Supplementary angles, 180 degrees. Okay? So don't forget those. Vertical angles, if you remember that vertical angles theorem, okay? Telling you that the opposite angle is going to be congruent. So if I look at this measure right here, 1 and 3 would be congruent, and 2 and 4 would be congruent to each other. And that's because of our vertical angles theorem. Those are known as vertical angles. If-then statements, if something is true, then this is true. So your hypothesis and your conclusion, your if is with your hypothesis, your then is with your conclusion. Okay, and then last but not least, properties of equality and congruence. I gave you a sheet to help you review for the Chapter 2 test, and that you could use on the quiz in Chapter 2, but not on the test in Chapter 2. So go back, see if you have that worksheet. I would definitely review those because you will be using these properties of equality and congruence. So make sure you review those. If you do not have that worksheet or that note sheet still with you, please come up and find me, because I want you to have that so you have it for review for the final. Okay, because you do need to look at those properties and know those properties. All right, so here we go. We have 3. So if we look at this, we have line AC, and it says right here that word bisects line segment XY. Whoa, look at that. Mr. Sheeman forgot his wonderful symbols. Don't forget those on the final. Okay, simple mistakes that we do not want to make. Okay, so bisects line segment XY. Find the distance between XC, YC, and XY. All right, so I want you to give this one a shot. See if you can figure it out without needing that refresher. Give her a shot. All right, so again, the line AC bisects this. Okay, it's that word bisects is very, very important, and that gives you the entire setup for this problem. It tells you the equation. Bisects. What does bisecting mean? It means cutting it in half. It cuts it in half. Okay, so if we look at XY, it's cut in half at point C. I have 2 equations, XC and CY. XC is going to be equal to CY because of that bisecting line. I then plug in 7x plus 4 is equal to 2x plus 19. Okay, I want numbers on one side, letters on the other. So I'm going to subtract 2x from both sides, and I'm going to subtract 4 on both sides. And I end up with 5x is equal to 15. Divide by 5. And my answer is going to be 3. And I'm done. Okay? I'm done. I found x. But wait. Don't forget. I am not done. I'm not done because the question didn't say find x. It says find xc, yc, xy. Okay, so make sure on your final, this has happened a couple of times in the past, don't let it happen to you. Make sure you read those directions, because it's going to be down to you to make sure you know what the question is asking you and you answer that fully. It says find xc, yc, and xy. So xc, if I look at that, well, xc we know is 7x, xc, not just x. xc is 7x plus 4. I plug in this 3 for my x, and I get 7 times 3 plus 4, which is going to be 25. So found xc. I'm done with that. But at the same time, I have also found cy, or yc. Notice in that very first statement we put up here, xc is going to equal cy. We don't have to re-plug in x, or re-plug in that 3 for cy. So we know that cy is going to automatically be 25 because they are the same. Then we have xy. xy is the entire segment. We could plug in both equations, set them equal to it, but we know that xy is going to be xc plus cy, which is going to equal xy. All right, that segment addition postulate. Remember that one. Okay, so if I add xc and cy, well, if xc and cy are 25, xy is going to be those added together, and it's going to be 50. And I'm done. Okay, so I found xc, which is 25. I found cy, which was also 25, and xy, which is 50. Answer the entire question. Don't just stop. Make sure you answer the question. Okay, find the measure of each angle. These are going back to our vertical angles theorem. Don't forget about these. Okay, so give this one a shot, see what you come up with, and make sure that you get all the answers. Give them a shot. All right, so I'm just going to start at the very top with angle 1. I know angle 1 is opposite. It is a vertical angle with that 41 degree angle. Because vertical angles are congruent, I know that angle 1 is 41 degrees. Angle 2. Angle 2 is going to be a vertical angle with angle 5. And I know for a fact that angle 1 is 41 degrees. Okay, now I have not sure what angle 5 is right now. I don't have the information down on my slide here. So I have to figure that out. How do you figure it out? Well, notice again, look at this. We have a 180 degree angle, a straight angle right there. So if I look at all of my angle measures, if I look at my 32 degree angle, my 41 degree angle, 36, and angle 5, if I add up all of those measures, it will equal 180. So if I subtract 56, 41, and 32 from 180, I can get angle 5. Okay, so if I look at that, I'm going to take 56, 41, and 32, add those together, and it's going to be 129. Okay, so I now have the entire measure here of these three angles is going to be 129. Looking for angle 5. Okay, or angle 2. They're essentially going to be the exact same thing. So angle 5 is going to be 180. And I'm going to subtract 129 from it. And my answer is going to be what? 51. 51 degrees. Okay, so I know that angle 5 is now 51 degrees. Found angle 5. Very easy, right? Because I just subtracted those three angles from 180 degrees. But I also found angle 2. Okay, those two are vertical angles. Okay, so because 5 and 2 are vertical angles, they're on the opposite side of that point there. Okay, angle 2 is also 51 degrees. 51 degrees. 51. That's how we say 51. 51 degrees. Sweet. Okay, not done yet. Still need to find angle 3 and angle 4. And based on our vertical angles for 3 and 4, angle 3 is going to be opposite that 56 degree angle. So angle 3 is 56. Vertical angles theorem again. And angle 4 is opposite that 32 degree angle. And that's going to be 32 degrees. Remember, vertical angles opposite of one another are going to be equal. Okay, but don't forget our other postulates, that angle addition postulate. We know those. We can subtract from 180, all right, and it will give you the correct measure. All right, sweet, just awesome math. Okay, here's our property of equality and property of congruence. Don't forget these properties, because what's the difference between equality and congruence? See if you remember the difference between equality and congruence. And I want you to try both of these problems. See if you can come up with the property without looking in your notes. Okay, without looking in your notes. Give this one a shot. All right, so this very first one, if you look at by is going to be equal to tu, then tu is going to be equal to by. Well, if you look at that, that's going to be a mirror of one another, right? A mirror. So when we look at that, it's also got that equal sign, and that's the difference between equality and congruence, is going to be that equal sign. Okay, so the very first one, by is equal to tu, then tu is equal to by. It is going to be that symmetric property of equality. Property of equality. Okay, so don't forget that one right there. Awesome. So now we're left with that second one. Okay, well, we know that it's got the congruent symbol. So we automatically know one piece of information. It's going to be a property of congruence because it's got that congruent symbol, not simple. Okay, so now we need to figure out what is QRS. Angle QRS is going to be congruent to angle QRS. Well, we know that from our identity. That's our identity property of congruence. Okay, so don't forget our properties of equality and properties of congruence. And make sure you remember those from past lessons, or past in chapter 2. Okay, so review that. Awesome. Okay, so right now we are on chapter 3. Last review in this one. I know it's a little bit longer, but stick with me. Okay, so relationships between lines. If you remember, this is the chapter where we started learning transversals and angle relationships. We started throwing in more theorems and started throwing in converse of theorems. This is going to be where you have your corresponding angles, your alternate interior angles, your alternate exterior angles, same side interior angles, but also the theorems that go along with it. Okay, that prove, if we have these theorems, then we have parallel lines. Or if we have the parallel lines, we know that those are going to be congruent to each other as far as corresponding alternate interior and alternate exterior. Okay. Then we also had translations. If you remember the translation notation, coordinate notation at the bottom here, where you had x, y, and then that's going to lead into your x plus something and y plus something, or y minus something. It's going to change. Remember your primes, going from a pre-image to an image. Okay, what's your pre-image? What's your image? And that all matters with that prime symbol. Okay, so make sure you look at that as well. All right. So look at your theorems and your postulates. This is where we got a bulk of that with the angle relationships that we still used in chapters 4, 5, and 6. Okay, especially in our theorems, our two-column proofs in chapter 5. But review those. Make sure you do remember them. But don't forget those converse. Don't forget the converse with that either. Okay, so let's get a couple going. All right, so the very first one, here's our two lines, or sorry, three lines. One's going to be a transversal. You have to, I want you to know which one's the transversal, okay, and which one are just going to be those regular lines, and then identify corresponding alternate interior, alternate exterior, and same side interior angles. All of them, okay. All right, so give this one a shot. All right, so there's several corresponding angles here. Okay, if you look at your corresponding angles, those are going to be on the same side of the transversal and the same side of their corresponding lines. Okay, so if you look at 2, it's going to be on top of their corresponding lines and to the right of the transversal. And this blue line here is your transversal. Okay, so corresponding is going to be angle 2 and 6. Okay, but also I have 1, if I have 2 and 6, I also have 1 and 5. Angle 1 and 5. Okay, I'm not done though. I still have on the right side of the transversal and the bottom part of my line, which is going to be angle 3. But it needs a corresponding angles, which is on the bottom side of their corresponding line and on the right side of the transversal, which is 7. Finally, I have one more. Okay, I also have left side of the transversal and left side of the transversal and on the bottom part of the transversal on both sides. Okay, so that's going to be angle. Ooh, that is a bad color to use. Yellow is going to be turned to purple. Oh, look, purple and yellow. Go Vikes! I didn't have the grays here. So angle 4 and angle 8 are also going to be corresponding angles. Okay, so we have those. Now, in this equation, or sorry, in this problem right here, would corresponding angles be congruent to each other? No. Why wouldn't these angles be corresponding to each other? Because we need those parallel lines. Because those two lines that you will see now in blue, those two lines aren't parallel, which means we cannot say that angle 2 and angle 6 are going to be equal to each other, or 1 and 5, or 3 and 7, or 4 and 8. Okay, they can't be, because those two lines are not parallel. They need to be parallel in order for corresponding angles to be congruent. All right, alternate interior angles, that's going to be on the inside here. Okay, don't forget what's the inside, what's the interior, what's the exterior. Your interior is going to be in between these two lines here, and your exterior is going to be on the outside of those two lines. So alternate interior on alternate side of the transversal. So I have 3 is going to be an alternate interior with angle 5. And last but not least, we also have angle 4 and angle 6. Alternate interior angles, remember, they are on the alternate side of the transversal and alternate side of their corresponding angles. By that, I mean angle 4 is on the left side of the transversal, bottom side of its corresponding line, where 6 is on the right side of the transversal and on the top side of its corresponding line. Okay, so there's differences there. Okay, they alternate. Alternate exterior is going to be the exact same idea, okay, except on the exterior, on the outside of those lines, which is going to be, start with angle 1. What is angle 1's alternate exterior angle? It would be 7. Ooh, don't forget your angle symbols, okay, because these are angle symbols, or sorry, these are angles that we're talking about. Last but not least, we also have angle 2, and that would be a alternate exterior with angle 8. Awesome. We're done with alternate interior. We're done with alternate exterior. Now that leads us to same side interior, meaning same side if you remember, we're talking about same side of the transversal and on the interior of our two corresponding lines. So in between. So still in this middle section here. Okay, so same side of the transversal on the interior of those two lines on the inside. So that would be 3 and 6. And also 4 and 5. Okay, so don't forget those definitions that we talked about before. Also, do not forget that 2 and 6 in this case are not congruent to each other. 4 and 6 are not congruent to each other. Okay, 4 and 5, those are same side interior angles. They're not going to be supplementary, all because those lines here that you see in blue, okay, are not parallel. Those need to be parallel in order for those theorems to come true. Okay, sweet. All right, so now it asks us, can we prove that B is parallel to C? Oops, look at this. I need to label B and C. So looking at those lines, is B parallel to C? I want you to be able to identify that and explain why. Remember, there's our parallel symbols. So explain why B and C can or cannot be proven parallel. Give it a shot. All right. So can these can they be proven? Yes. Yes, they can be proven. Now, just as important as your yes is going to be your explanation. Okay, what can I say, or why can I say that they are congruent? Or sorry, not congruent, because they are parallel. Well, we have two measures here, 104 and 104. What type of angles, okay, is the relationship between those two 104-degree angles? These two are corresponding angles. Okay, because they're corresponding angles and they are congruent, that tells me they are parallel. Okay, and the reason behind it is there's a theorem that goes along with that. Okay, so if I look at that, all because of the corresponding angles. Remember, this is now opposite. It is the converse. We don't have them. We don't have them parallel, or sorry, we don't have them congruent right away. We need to prove that. So in order to prove that, we're going backwards. We have the angle measures. Now we're going backwards. That's the converse. Okay, so corresponding angles converse. All right, sweet. Again, here is going to be, this is the last slide that I have for us today. I know it's long, but let's try to finish, just knock this out and describe the translation using coordinate notation. All right, give this last one a shot. All right, so now when we look at translations, we need to figure out which one is our image, which one is going to be our pre-image. All right, and that all matters with our prime symbols. Okay, so if I look at which one's my pre-image, which one is my image, well, my pre-image is going to be the very first image. It's before the image happens, or before the image happens. Okay, so my image is marked with the prime symbols, where my pre-image is just the regular letters unchanged without those prime symbols. Okay, so if I look at this, I am changing A, B, C to A prime, B prime, C prime. Okay, so how much do I change? And I need to make sure that it's true for all. It's true for all of the points. So if I look at C, how much does C change? Well, let's look at the change in X. All right, I have 1, 2, 3. So it changed 3 units. Now, is that going to be a positive 3 units, or is that going to be a negative 3 units? Positive. I moved right 3. So I went positive 3 units, which means I moved to the right. Remember, it's the same idea as the coordinate pair. If I move right, I go positive. If I move up, I go positive. Down is negative, left is negative. Okay, so now I I moved across. Now I'm going to move up. 1, 2, 3, 4, 5, 6, 7. So I went a positive 7 units up. Now, is that true for A and B, to A prime and B prime? You tell me. What do you think? Yes, that is also going to be true for A and B. You will notice that it is A and B is going to be the exact same. They went right 3 units and up 7 units. Now, coordinate notation. If we remember coordinate notation, okay, what are we doing to each x and y? So if I give a point on here, what happened to each x and y? Well, the x went right 3. The y went up 7. So I start with my initial unit of x, y, or my initial coordinate pair of x, y. That changed. That changed. What did it change to? Well, that changed right 3 and it went up 7. So my x added 3 when my y added 7. Okay, so every point that I have, A went right 3 up 7, and I could plot that. Okay, C went right 3 and up 7, and I could plot that point. Okay, so that translation, remember, it slides. The shape didn't change at all. It slid to A prime, B prime, C prime. Okay, so make sure that the translation, all the points slide those same units, then write it in coordinate notation. My coordinate notation is right here. Okay, I know today was long. We will have a worksheet to go through this chapter 1, 2, and 3 review. We are going to have one more review video for 4, 5, and 6 tomorrow. Make sure if you have any questions about anything that's going on that all of a sudden just pops into your head, make sure you ask me, because I want to make sure that this test is not, I'm not here to trick you. I'm here to see if you remember. Can you comprehend it, and do you keep that information in your head? And do you remember the information? Okay, that's the importance of this final. Okay, I hope you all have a great day, and I will talk to you later. See you guys.